Okay, so I hope all of you can see the screen. Let's start with our application of integrals part. Okay, so in case if you are not familiar with application of integrals, okay, stay tuned because this is something very important. Okay, let's start with our first problem on application of integrals. The question says find the area of the region bounded by the ellipse. Now in the question here it is given ellipse. Sometimes it is not given. Okay, they'll simply say find the area of the region bounded by the curve. Okay, so you should be familiar with the equations. Okay, here this is an equation of ellipse. Okay, now be very careful with the equation of ellipse and equation of circle. Okay, because both have the same kind of expressions, x square plus y square, and there will be something here. Okay, this is an equation of circle passing through the origin. What's our standard equation of circle? X minus h whole square plus y minus k whole square, and that is equals to r square. But in case if the equation looks like this, x square upon a square plus y square upon b square equals to 1, then this is an equation of ellipse. Now be very careful with this a and b, the numbers which are written below x square and y square. Why we have to be very careful? Because they will decide along which axis the given ellipse is. Here a is 16, root under 16, a is here 8 and b here is 3. Correct? Because the equation of ellipse standard equation is x square by a square plus y square plus by b square equal to 1. So a must be 4, sorry, what I am doing here. This is 4. A is 4, 4 square is 16 and b is 3. So if a is 4 and b is 3 for this particular equation, let's plot the ellipse. So which one is greater? Is a is greater or b is greater? A is greater. And a is below x-axis. So the ellipse will be along x-axis and it will look like this. Okay, it will look like this. Sir, what if b was greater than a? In case b was greater than a, then the given ellipse will look like this. I hope this is clear. Okay. So since a is greater than b here, this is the first thing you have to draw. Sir, can I solve the problems of application of integral without plotting the graph? No, no. Okay. You can never solve a problem without plotting a graph. Okay. Now there will be some questions which you can solve, but that will be useless. Okay. Because the graph will tell you the proper area. Now what is a and b for an ellipse? A is your major axis. What is major axis? Here is the major axis for this ellipse is x-axis and the minor axis is y-axis. Okay. Why x-axis is major axis? Because a is 4. So if a is 4, let me take this as this will be our 4, 0. And what will be this? This will be our 0, 3. Okay. We found our coordinates? Yes. Okay. So always remember, first thing is to plot the graph for the problems from application of integral. And second thing what is important is to put the coordinates. If your coordinates are perfect, you will get the perfect answer. If your coordinates are not perfect, you will not get the perfect answer. Okay, great. Now always remember area under the curve. Okay, integration of a given function with respect to x-axis will give you area under the curve in along x-axis. So what I will do here, let me remove this. Okay, let me repeat again. Integration of a given function with respect to x-axis will give you area under the curve. So here on y-axis, what is the value of x? 0. What's the value of x on x-axis here? 4. So if you look at this, okay, this is simply x value is going from 0, 1, 2, 3, 4. Okay, it will go 0, 0 0.1, 0 0.2, 0 0.3 till 1, 2, 1.1, 1.2, then 2, 3, and finally it reaches to 4. Okay, so x is going from 0 to 4. Okay, and that is below what? That is below the ellipse. So 0 to 4, listen very carefully. Each question will help you to understand the concept of application of integral in case you don't know. Okay, so 0 to 4, who is going? X-axis is going 0 to 4, right? Okay, if you want to go on the right hand side, it is x-axis. If you want to go up, it is y-axis. If you want to go down, it is y-axis, and if you want to go left side, it is again x-axis. So here we are going from 0 to 4, because on this line completely, look at this red one I am drawing here. On this line, x is always 0. So your x is going from 0 to 4 maximum. And this area under this curve, what is the equation of this curve? Equation of this curve is given in the problem, which is this. So always remember, as I am taking the limits of x-axis, I have to integrate it with respect to x-axis. Let me repeat, I am taking the limits for x-axis, I will have to integrate with respect to x-axis. And when you are integrating with respect to x-axis, here the function should be of x-axis only, okay, x only, right? So how do you find a function of x from this equation? Y square by 9 is equals to 1 minus x square by 16. And y square will be equals to 9 times 1 minus x square by 16. And this will give you 9 by 16 into 16 minus x square. That is your y square. So that's y square, that's not y. Be very careful, you have to substitute here y. So what will be your y? Sir, y will be root under 9 by 16, 16 minus x square. That is our y. So we always integrate y, because y is a function of x. Because we are putting the limits from 0 to 4, that's a limit for x-axis. And we are integrating with respect to dx. So let's put here, let's substitute here. Let me remove this and let me substitute here. That will give us the area of this shaded portion, which is the blue color part. So this will be 9 by 16. 9 by 16 is 3 by 4 root under 16 minus x square dx. So this will give us 3 by 4 integration from 0 to 4, okay, root under 16 minus x square dx. Let me minimize it and let me paste the formula required for this particular integral. So this is what? This is our a square minus x square, and our a square minus x square from the formula sheet will be this. This is our formula for 28th formula, a square minus x square. So let's substitute here. This will give us 3 by 4 integration of a square. A is what? A is 4, right? A square is 4 square is 16. So a is 4. So it will give you what? It will give you x by 2 root under a square minus x square plus a square. So 4 4s are 16 by 2 sine inverse x by 4 from 0 to 4. Let me repeat. This is nothing but root under 4 square minus x square from this. Correct? So now we will substitute our limits. So the upper limit, when you substitute, let's see what we get here. So putting the upper limit 4 by 2, and when I put here 4 square, this will completely reduce to 0. So when you put 4, you can't put it in the first term. You can put it in the second term. It will be 16 by 2 sine inverse 4 by 4, which is 1, minus, when you are putting 0, you can't put it 0 here. Why? Because sine inverse 0 is 0 and the second term will reduce to 0. Let me repeat. When you put the lower limit in the second part of this particular outcome, this will reduce to 0 because sine inverse 0 is 0. And when you put it in the first term, here putting x as 0, this will give you 0. So both the terms are reducing to 0. So this will give you 3 by 4 into 16 by 2. 16 by 2 is 8. Sine inverse 1 pi by 2. We have already done inverse trigonometry. So sine inverse 1 pi by 2. Pi by 2. Okay. Okay. Upper limit minus lower limit we did. So it's always upper limit minus lower limit. When we put upper limit 4, okay, you will get this. Okay, when you put the 4 here, look at this first part. When you put 4 here, this 4 4s are 16. So first part reduces to 0. And when you put it in the second part here 4, this will give you 16 by 2 sine inverse 1. Done with the upper limit. Now let's put 0. So putting 0 here in place of x, this will make this complete thing 0 first term. And the second term sine inverse 0 over here, this will make it complete 0. So second term is completely 0. Okay. Now sine inverse 1 is what? 90 degree. So let's cancel out 4, 2 and 2. So we left with 3 pi. Be very careful, this 3 pi is the area of this blue region. Which blue region? Which you can see. But such how many blue regions are there? 1 here, 1 here, 1 here. So these are total 4 regions. This is the area of one part of this ellipse. And since it is a symmetric ellipse is a symmetrical figure, geometrical figure. So all 4 will be 4 into 3 pi. This 3 pi is the area of first quadrant. So multiply it with 4, that will be 12 pi. So correct answer for this is option A. Okay. Let me recall what we have done till now. Okay. Again, each problem we will increase the difficulty level. Initially, let me repeat what are the steps. The first step is you have to look at the equation and recognize what is your figure, geometrical figure. Okay. First one is recognizing geometrical figure. Now, in this case, it's already given in this problem that it is an ellipse. It might or might not given, okay, in the exams that they can write it as find the area of the region bounded by the curve. So, in that case, by looking at the equation, you have to recognize which curve they are talking about. Second thing, draw the figure. If you will not draw the figure, there will be two issues, okay. Now, in competitive exams, they will not worry about that thing, but still, if you don't draw the exam, in competitive exams also, you will not get the answer. So, draw the figure, that is must. Okay. Third thing, find the coordinates. Find the coordinates. And finally, check what you have to integrate. Okay. So, integration is the last part. That will give you the final result. So, if you have done you have recognized the equation, but your figure is wrong, rest everything will get wrong. If you have drawn the figure correctly, but for competitive exams, they don't care. So, you will not get marks, but in board exams, you might get 1 mark. You have found the coordinates wrong, rest of the things go wrong. Okay. And if you have done everything fine, but you have not done integration wrong, completely wrong. Okay, now we have some queries. What, sir? But 3 pi is already the area of the region, no? So, of 3 more regions area, so must find, right? So, we must multiply with 3. Okay, so if you are confused with this, that sir, 3 pi is already the area of one region. Now, you have to add 3 more, right? So, can I make it like this? The 3 pi of the first quadrant plus 3 pi of the second quadrant plus 3 pi of the third quadrant plus 3 pi of the fourth quadrant. Now, it's better. Okay, this was for the first one we found, this will be for the second one, this one will be third one, this one will be fourth. Okay, that's why I multiplied with fourth. Okay, 4 and not with 3. I hope your doubt is clear now. Okay, let's move to our next question. Okay, so what is important? Okay, those 4 or 5 points which I have written. So next question says find the area of the region bounded by the parabola. Now, sir, I am not familiar with parabola, let's say. In case if you are not familiar with parabola, there are 4 equations. Let me all explain first and then I'll proceed to this question. Okay. What are the 4 parabolas? Let me draw one by one. So, if it is like this, if it is like this, okay. In this case, it is on the right hand side along x-axis. So, this must be x equal to y square. Sir, but often I get confused. In exam I forget. Okay. If you are one of those, then just remember, do it mentally. If you put here 0, 1, 2, 3, 4. Y square we know, or either it will be x square. We know that. Okay. So, see here which one is increasing rapidly. If my x is 0 in this equation, what will be my y? If my y is 0, what will be my x? X will be 0. If I put y as 1, x is 1, correct? Somewhere here this point will be. But if I put y as 2, x becomes rapidly 4. It is changing rapidly. X for y3, x will go further ahead. 9 will be somewhere here. Look at this coordinate. This will be 9 here on this x-axis. So, who is changing rapidly? X is changing rapidly. Y is the values you are taking in. So if you put y as 0, you are getting 0. If you are putting y as 2, you are getting x as 4. If you are taking y as 3, x is 9. If you put y as 4, your x is 16. So who is changing rapidly? X is changing rapidly. So this will be the curve. While if you take the just another case, okay, I will plot it here only because then I will remove altogether. If I take y equal to x square, so now we have to insert our values in which place? In place of x. So if I place x as 1, my y will be 1. But if I x as 1, y will be 1. Let's say it is somewhere here. If I put x as 2, y will be where? On the right hand side or on the top? Think about it. If I put x as 2, y will be 4. So that 4 will lie on the right hand side or on the top? It will be on the top. So curve, which one is increasing rapidly? Y-axis. So this blue curve is y equal to x square and the black curve is x equal to y square. You have to just remember that. And for simplicity, if it is linear, that will decide the axis along which the parabola is curved. So what about if there is a negative sign? If there is a negative sign, y equal to minus x square, then simply this curve will be here. And if it is x equal to minus y square, it will be curved on this side. So these are your parabolas. I hope this is clear. Okay. So this is your parabolas. So in this case, let's first do our first task. We have already found our equations. We have recognized our equations. Let's plot the curve here. So y equal to x square. So it is along y-axis. So y-axis, let me plot here. This will be y equal to x square here along y-axis. Okay. It's okay if you can't draw it perfectly, okay, symmetric, but it's perfect U. Okay, perfect U it is. Okay. And these are going to infinity because if x is infinity, y will be also infinity. They are going to infinity. Okay. What about modulus? Again, I am saying, in case if you don't know how to plot the graph, simply imagine if your x is 1, y is 1. If your x is 2, y is 2. If your x is 3, y is 3. If your x is 4, y is 4. If x is infinity, y is infinity. So the curve will go straight away like this. This green part is your for all the first quadrant. What if x is minus 1? Sir, if x is minus 1, y is still plus 1. So x minus 1 on the left hand side, but y plus 1, so that will give you in the second quadrant. Okay. This will be, this green part is a equation of, here this green part is this one, modulus function. Okay. Now, what instead of modulus, if there was no modulus, okay, this will go straight like this. Okay. Like this here. Okay. This red part shows if you take x as negative, y will be negative. Okay. I hope this is clear. So we have already plotted our curves. The question is saying find the region bounded by this. Okay. So my this parabola looks quite weird on this side. Let me make it better. So let's make it like this. Now it looks better. Okay. Now be very careful. These are symmetric curves. Okay. So area bounded on this side will be equals to area bounded this side. Okay. So both the gray regions, they are same. Okay. They are equal. So simply if you find the area on the right hand side in the first quadrant, simply multiply it with 2. That will be your answer. Let me repeat. Find the area in the first quadrant and multiply it with 2. You will get the, okay, both the areas. Okay. But sir, we have found the diagram. We have recognized our equations. How to find the coordinates? Now listen very carefully. If you are given with any two equations, then the intersecting points you can figure out by substituting any one of the equation in any second equation. Let me repeat. If you substitute any one of these two equations in the other one, you will get the intersecting points. So you mean if I substitute y as x square here, or if I substitute y equal to x over here, I will get the same result. Yes, you will get the same result and you will get an answer for x. That is your intersecting point. Can I substitute x is equals to y in the first or second? It's your choice, but I am integrating with respect to x. So I will find the limits only for x. So y equal to x square, I am substituting in the second equation, it will become x square equal to modulus of x. Now modulus of x I am removing because I am finding in the first quadrant. Okay. So whatever you will get it in the first quadrant, we will get the similar in the second quadrant, that I will explain at the end. So x square equal to x. So x square minus x equal to 0, and taking x here, it will be x minus 1 equal to 0. So x can be either 0 or x can be 1. Now at this point, x can never be 0 at this point. Okay. Which point? Let me name it point A. Okay. So x has to be 1. And if it is x equal to 1, here B point will be x equals to minus 1. Okay. Yes. We can verify that. How do we verify that our answer, this is our intersecting point or not? If I substitute x is equals to 1 and minus 1 in both the equations, they should give me the same value of y. Let me repeat. This is just to check. You don't have to do in the board exams, neither you have to do it in competitive exams. This is just for self-satisfaction that yes, I have got the correct answer. So putting this x is equals to 1 in the first equation, you will get y equal to 1. And putting x here in the second equation, you will get y equal to 1. Putting x as minus 1, it will be y equal to minus 1 square, which is 1. And putting minus 1 in the second equation, it will be y equal to modulus of minus 1, that is again 1. So for both x values, corresponding y values are equal in both the equations. Yes. So your points are perfectly fine. No problem in that. Okay, let's go back to what in the previous problem steps. What are the different steps we have learned? The first step is find the equations. Second is draw the diagram. Third is find the coordinates. In this problem, what we learned? We can find the intersecting points by substituting first equation in the second equation. Okay. Third important thing. The last part for this problem, again you will learn something new. You have to find the area of this gray part. Correct? To find this area we can find, you will say, sir, directly this is below the green one. Simply integrate the equation of this green line from 0 to A or O to A. You will get the area under the curve. But be very careful when you are integrating from O. So here it is origin. We know that 0. And what's A? A we just now found 1. 0 to A. And green one. Green one is what? Modulus function. So it's in the first quadrant. So it will give you x only. No need of taking the negative sign. So x dx. 0 to 1 x. What is x? Y. Look at this equation. So this will give us what? This will give us area under the curve. And what is the area under the curve? Be very careful. This will include this black portion also. Because 0 to A, when you integrate the green line, it will give you the complete area. And in that complete area, this black portion is also there, which we don't want. We just want gray part. So minus from 0 to 1 parabola. Yes? If you look at this blue part, if you integrate from 0 to 1, this will give you area under this curve, which is this black part. So 0 to 1 parabola. What is parabola? X square dx. So this will give you integration of x square by 2 from 0 to 1 minus x cube by 3 from 0 to 1. And this will give you 1 by 2 minus 0 and minus 1 by 3 minus 0. So that will give you 3 to the 6, 3 minus 2, 1 by 6. Now 1 by 6 is the area of this first gray part. We want the total because they have not specified that you have to only find for the first quadrant. You have to find total. So total will be into 1 by 3. Option C. Let's move to third one. Let's see the third one. Okay. Question number 3, it says the area of the region bounded by the curves. Now look at this. This time it is not specified if it is a line, if it is a parabola, if it is a circle, if it is a ellipse. Okay. So now you have to focus because this type of questions will arrive in competitive exams. The area of the region bounded by the curves y equal to x square by 2. Okay. See here what is happening. This looks like a parabola, but it is not a parabola because of this plus 2. If I remove this plus 2, I will simply get a parabola, y equal to x square. So this plus 2 is making it weird. This is our first equation. So it might be a parabola that we will draw and check. Second equation, y equal to x, very simple, so straight line. When there is x to the power 1 and y to the power 1 in a given equation, all are 1 power, linear equation, it's an equation of straight line. Okay. X is equals to 0, it's okay, x equal to 0, that what it signifies, that also we will see, and x equal to 3, what it signifies, that also we will see. Okay, so we have written our equations, let's start plotting them. So let me first draw our quadrant. Diagram is very, very important because diagram will decide what you are finding. It's not like blindly you are integrating from 0 to 3. If you are integrating from 0 to 3, which one will you integrate? First one, second one, what? Okay, so please don't follow that blindly. Without diagram, it will be useless. Okay, let's understand the first equation, that is y equal to x square plus 2. So if there was no 2, then y equal to x square. Let's start with this thing. If I put x as 0, y will be 2. So the curve is starting from here. This is your, let's say, 2 on y-axis. After this, if I increase value, all the values will be following parabolic equation. So this is my initial point, and after that, this is a parabola. You can check it. It will gradually increase like this, like a parabola. If I put x as 1, y will be 3. If I put x as 2, it will be direct. 2 2s are 4, 4 plus 2, 6. Rapidly, y is increasing. 3 3s are 9, 9 plus 2, 11. So rapidly, this is increasing. But what is important about this 2 here? This 2 tells us that the graph is not starting from the origin. Let me repeat, this 2 is telling us that graph is not starting from the origin. Okay, if 2 was not there, then obviously if x is 0, y will be 0. But here if x is 0, y will be 2. So that's quite important part about this. So this red curve represents this parabola. Let's move ahead and see y equal to x. So this is our y equal to x. I have already drawn this in the previous problem and explained you that this is your y equal to x. If you are confused why it is y equal to x, the blue line, simply take x is equals to 1, y will be 1. If you take x is equals to 2, y equal to 2. If x equal to 3, y equal to 3. X equal to minus 1, y equal to minus 1, and so on. You can take it in the opposite direction. Next is x equal to 0. Now x equal to 0 is on y-axis, right? So no need of plotting it. X equal to 0 means y-axis. And x equal to 3. Now be very careful with this. X equal to 3 means somewhere here. Anywhere here. X is equals to 3. You can stretch this line, the brown one, down and up into the infinity. On all the points on this brown line will have x equal to 3. I hope this is clear to all of you. Okay. Now we have to read the question very carefully. Find the area of the region bounded by the curves. Be very careful. They are talking about this area. Which one? This area. Sir, why not this small triangle one? In that small triangle one, the lower one, okay, that is between the x-axis, the blue line and the brown one. But this area, this is between x equal to 0, which is our y-axis, x equal to 0, y-axis. The red one represents our first equation. The brown one represents x equal to 3 and the blue one represents our y equal to x. This will clear your whole concept, I am telling you. So what we have done till now, out of those steps I have told, we have recognized our equations. We have plotted our graphs. We have to find our coordinates now. That's the third task. Now just keep it in your mind, these steps. Okay. That will help you so that you don't get stuck anywhere. Okay. What is this point? Sir, 0, 0. Okay. use another color, 0, 0. What is this point, sir? 0, 2. What is this point? Sir, we don't know. What is this point? Sir, we don't know. So the brown one is going and hitting which curve? The red one. The brown line is cutting the red line. So the brown line is represented by x equal to 3 and the red line is represented by this. So our our x is equals to 3 and y equal to x square plus 2. Let's substitute this x equal to 3 in our red equation, which is y. So let's substitute here, okay, to get the value of, but that will give us the value of y. We have to find the value of x. No. Now you will say, sir, if all the points on this brown line is having x3, then straight away this point will be 3 only. Now why we have to substitute? No need of substitute. Clear? Let me repeat again. For this brown line, all the points on this brown line is 3. So this coordinate will be 3. Okay. What will be this coordinate? Here also it will be x will be 3. Great. Okay. So we found our all the coordinates without substitution because this was a linear x equal to 3. So I had all the points on this brown line is 3. Okay. Now final task, that is integration. Listen very carefully. Now this is something important. If I integrate from what I am integrating? X-axis. Always I integrate with respect to x because it becomes very easy. So here what is the x-axis value? 0. Here what is the x value? 3. Equation of parabola x square plus 2. This will give me what? This will give me this complete area which is marked by cross. But what we don't want? We don't want this triangular area. And this triangular area is below what? Below the blue line. So minus 0 to 3 equation of this blue line. What is equation of blue line? X dx. I hope this is clear. Anyone who is confused can speak up. Otherwise, let's integrate it. It will be x cube by 3 plus 2x and the limits are 0 to 3 minus x square by 2 from 0 to 3. So this will give us, putting the upper limit, 3 3s are 9 3s are 27 by 3, okay, and plus 3 2s are 6 minus 0 minus 3 3s are 9 by 2. So this will give us 6 here and 3 2s are, so 2 7s are 14, or let me just simplify it. Let me make it 2 only, 3 9s are, and this will give us 2 18 plus 12 minus 9. 18 minus 9 is 9, 9 and 12. 9 and 12 will be 9 to 11, 21 by 2. 21 by 2 is option C. Okay. Let's move to our next question. So our next question is our question number 4. Let's see question number 4 here. Okay. The question says, pay attention. The question says, find the area of the region enclosed by the parabola. Very simple. And the line. Okay. So let's see here. Now some students, they get confused with the line if it is not x equal to y. Okay. Let's see how to plot such a line. So this is our coordinate axis. And first of all, parabola. So y equal to x square. Y equal to x square matlab this will be along this side and this will be along this side. Okay, y equal to x square. Now next is y equal to x plus 2. So always take origin first. If x is 0, what will be y in that equation? Y equal to x plus 2. If x is 0, y is 2. So that will be this point. Okay, great. And if y is 0, what will be x? X is, sir, minus 2. You got your 2 points? Let me repeat. If x is 0, y is 2. And if your y is 0, x is minus 2. Correct? So you got 2 points from your coordinate axis. Let's join these 2 points. So we have joined our 2 points and find the area of the region bounded by this. Okay. Now be very careful here. Okay. Why? We have to find the area of the region bounded by the parabola and the line. Yes? Not with the parabola and the coordinate axis, not with the line and the coordinate axis. So can I shade it? Let me shade it to make it clear that this area they are looking for, the first one, and this area they are looking for. Okay? Pay attention. Huh? I will, because this will clear more concept. This is your area A and this is your area B. You have to simply add them, A and B. Done with your diagram? What is the next task? So first find the coordinates. Okay. So let's take our equations. X square equal to y, and equation is next one is y equal to x plus 2. Let's substitute y equal to x plus 2 in the first equation. It will give you x square is equals to x plus 2, or x square minus x minus 2 equal to 0. This can be written as x square minus 2x minus x minus 2 equal to 0. And taking x common, it will be x minus 2, plus it is x minus 2, and taking 1 common here, it will be x minus 2. Middle term splitting, simply x plus 1 and x minus 2. X is equals to minus 1 and x equal to 2. These are the two coordinates. X is minus 1 and x is 2. Now this is obvious that this can't be minus 1. So this is 2 and this is minus 1. If the line is cutting at 2 points on the parabola, you will get 2 points. Sir, what if I have an equation of curve like this? This is my curve, okay? And here it is cutting again at 2 points, or maybe it is cutting at third point also. Let me draw it like this, okay? Like this. This is my curve, okay? Like this. So if it is cutting more than 1 point. So if you put the equation of this red curve in this parabola, you will get all these points when you solve it, okay? So x is equals to minus 1 and x equal to 2. That are the points we have already found. Okay. Now it becomes very easy. What is the x value on this point? 0. Correct? X value is 0. Now only focus on x-axis. Otherwise, if you are a beginner, you will get confused. This is minus 1, that is 0, and that is 2. I am integrating it. What? I am finding first area A. So area A, integration from 0 to 2, equation of line, which is x plus 2, that will give us the complete area up till here, this whole area of this box. We don't want that. We just want this shaded portion. So minus this area below the parabola. So from 0 to 2 parabola, which is x square dx. This is giving me the area of A. Area of A is done. First one minus that. Okay, great. Next is area of B. Area of B. B is starting from this point. Look at this point, minus 1. So it is going from minus 1 to 0. If I integrate minus 1 to 0, I will get equation of line x plus 2 dx. I will get this area. Let me use a different color. This area I will get. Is it B? No. Why? Because there is a small portion here which you can't see it because the diagram is quite small. This small portion will also be included in that. So what you have to do? Sir, we have to remove that. So minus 1 to 0, and that small portion is below the green part, right? And green part is parabola, x square dx. I hope this is clear. Let's solve this and add both the areas. That will be your answer. So integration I am doing fast because we have done already integration. So x square by 2 plus 2x from 0 to 2 minus x cube by 3 from 0 to 2. This is for area A. Solving here. So putting here upper limit 2 2s are 4 by 2 plus 2 2s are 4 and minus 2 2s are 4 2s are 8 by 3. So this will give you 2 and 4 plus 2 6, 6 3s are 18 minus 8 10 by 3. That's your area due to A. Let's see the second one. That will be x square by 2 plus 2x from minus 1 to 0 minus x cube by 3 from minus 1 to 0. Putting here limits, it will become 1 by 2 minus 2, 1 by 2 minus 2 and putting minus plus 1 by 3. So that will give you how much? 2 2s are 4 and 1 minus 4. 1 minus 4 is minus 3 by 2 plus 1 by 3. Minus 9 plus 2 upon 6. Minus 9 plus 2, that will give you minus 7 by 6. Now be careful, minus 7 by 6 is the negative answer. Negative answer, area is always positive. So we always take the modulus. So 10 by 3 plus 7 by 6. So this will give you how much? 6. 3 2s are 2 10s are 20 plus 7. So that will be 27 upon 6. 3 9s are 3 2s, 9 by 2. Option B. Anyone who has not understood, speak up. So main thing is to figure out that which area you are talking or dealing with. Okay, these are few things you should be clear with. Let's deal with another question. So the next one is our fifth one, which is here. Okay. First equation here is y equals to 2x minus 2. Second is y equal to minus x and x-axis, which means only first quadrant they are dealing with. Okay, or maybe only with maybe second also, because the equation is minus x. Okay. Great. So let's see here. Y equal to 2x minus 2 and y equal to minus x. Okay. So putting here x as 0 in the first equation, we will get y as minus 2. So x as 0, y is minus 2. So this must be passing here minus 2. And if y is 0, then x will be how much? X will be 1. So if y is 0, x will be 1. So this is your point. That you can substitute and check. So this is our equation of this line. Okay. In the first one I substituted. Let's move to the second one. If x is 0, y is 0. And if x is 1, y is minus 1. Y is minus 1, which is here. Okay. And if x is minus 1, y is plus 1, which is here. Okay. Let's join all these points. So this will be our next. Great. Now the question says, find the area of the bounded by the line, this and x-axis. Which means they are talking about which area? They are talking about this region. Correct. And to figure it out, what we have to do, we have to check how our x values are going. So x is over here 0 and x over here is 1. If we integrate from 0 to 1, this black line, this will give us this complete area. But we don't want that area, right? So what we will do? We will subtract the area bounded from, but we can do one more thing. We can find the intersecting points and solve it. Okay, let's find it using that. Okay. First, let's find the intersecting point. Okay. So let's substitute y equal to minus x in the first equation. It will be minus x equal to 2x minus 2, and minus 2 taking on the left hand side 2, and that will be 3x. So x is equals to 2 by 3. This is the point, 2 by 3, and this is that 2 by 3. So if I go from 0 to 2 by 3, the blue line, I will get this area. Let me repeat, if I go from 0 to 2 by 3, I will get this area. Still that blue region is not done. Plus 2 by 3 to 1, the black line. Done. That will give me the answer. So 0 to 2 by 3, blue line. What's the equation of blue line? Minus x dx. Plus 2 by 3 to 1, the black line, 2x minus 2 dx. Now integration of minus x square by 2 from 0 2 by 3 plus this will give me 2x square by 2 minus 2x from 2 by 3 to 1. I hope this is clear to all of you. Now let's substitute these values. So here it will be, putting the upper limit in the first one, it will be 2 2s are 4 by 9 2s are 18 minus 4 by 18, plus in the second one, in this part, putting the upper limit, this will give you, this cancels with this, 1 minus 2 and minus lower limit 4 by 9 and minus 4 by 3. So this will be minus 4 by 18 plus minus 1, and that will be minus 9 here, 4 and minus 3, 3s are 12 here. So this will give us minus 4 by 18, minus 1, minus and minus plus 8 by 9. 18 here, minus 4, minus 18, and 9 2s are, so 2 8s are 16. So that will give us minus 4 minus 2 upon 18, minus 6 by 18, and that's 1 by 3. That's your answer.